Here is the question. We want to find the volume rotated about the y-axis and bounded by the following functions. Y equals x squared, x equal 2, y equals 0. Here is y equals x squared. It's a parabola. Here's x equal 2. I'm going to try to draw it real nice. Okay, it touches at some point. There's x equal 2. And then y equals 0, which is the x-axis. And so we're talking about this piece here. We want to rotate it. So when it's rotated, it's going to look like a cylinder with the middle cut out. And the only parts that are solid are there. So I don't know, it's some kind of it's almost like a glass of some kind or a cup. And I don't know if I can do that part, but so the middle is like cut out, and I'm not a very good artist, so it's hard for me to draw it. But that's what we're trying to get. So you may remember what's called the ring method or the disc method. When it's going like this, we have to find these little slices here, one stacked on top of another. And how do we find that? We find, well, the volume equals pi r squared. In other words, these things are going to turn into circles or stack on top of each other, make a cylinder. So pi and then the radius squared of the circles, that's the area of the circle, and then stacked one on top of the other is h, pi r squared h. Here's the r part. In order to find just this piece, we just want this outer part here. And to find the area of that outer part, we take the whole radius, the area of the thing with the whole radius, which is usually called big R, minus the area of the outside, minus little r. So it's big R squared minus little r squared. And then to stack them all on top of each other, that's the dy part. Because remember, this is around the y-axis, not around the x-axis. And, oh, that's terrible. We multiply that by pi, and then we need to find out it goes from where to where. Well, it goes from 0 and it goes to where x equal 2 touches y equals x squared. Well, where do they touch? Set them equal to each other. Or not set them equal to each other. Plug in 2 for x. Y equals x squared equals 2 squared equals 4. So 0 to 4. So the volume equals pi. Well, what is big R? What is this whole radius? The whole radius is this distance all the way to x equal 2. So it's 2 squared. We already found it was 0 to 4. Minus, what's this outside radius? This part. Well, it's just the function, but not y equals x. It's got to be x equals something y. So if y equals x squared, take the square root of both sides. X equals plus or minus the square root of y. And we're in the first quadrant, so only the positive. X equals square root of y. So minus square root of y squared. And then again, the height is dy. They're stacked all one on top of each other. So we can rewrite this as volume equals pi, integral 0 to 4 of 4 minus y dy. And that's going to equal pi times, well, the integral or the antiderivative of 4 is 4y minus y squared over 2. We have to evaluate that from 0 to 4. When you plug in 0, it's going to be 0, so we just have to evaluate the 4 part. 4 times 0 is 0, minus 0 squared over 2 is 0. That changes nothing. So it's going to be, I'll write it over here, pi times 4 times 4 is 16, minus 4 squared is 16 over 2 is 8. So that's going to equal 8 pi. That's it. The volume rotated about the y-axis in a disk, which actually becomes a washer or a ring, is 8 pi.